Good morning.
Good morning. Can you hear me?
Good morning. How you doing?
Good. How
It's
are you?
really early this morning where Ivan is. So thank you everyone for joining today. And with us this morning, we have Ivan Font, and we're going to talk a little bit about WebAssembly and what we think about it, what's missing, maybe what's good, and where we think we're going, maybe. What do you think, Ivan?
Yeah, I think that'd be great. That's what I'm prepared to talk about here. So I'm glad
Cool.
we can agree on
I,
that.
I can't do enough to introduce Ivan. He works with me a little bit, and he, uh, he does a lot of stuff. So why don't you let people know what you do and who you are and how you came about working with WebAssembly.
Yeah. So my name is Ivan Font. I've been at Red Hat for about 7 or 8 years now. I come from an embedded Linux background originally, but I switched to work on a lot of cloud software at Red Hat here. And I've worn a lot of different hats at Red Hat, but most recently I've been focusing on WebAssembly and understanding the technology, seeing its capabilities, seeing how it can be used, and doing a lot of learning along the way. So I'm happy to share any of that here today.
Excellent. So,
Cool.
Rob, tell me
Yeah.
if I need to pay attention to WebAssembly or I need to learn how to use WebAssembly. And so far, I've still been on the fence, right? And I just downloaded the state of WebAssembly report from somebody. Maybe I'll find, see if I can find a link. I can share the link in chat. Which, by the way, throw any of your questions in chat. We'll get to those during the presentation. And so, hopefully, let's see. You can convince me that I should look. I should be getting into WebAssembly.
Well, I think you should. But I started as I've been doing C++ for more than 25 years, and I know that you're doing Java mostly, and I think I've recently had that epiphany where I switched over to using Rust with WebAssembly because it was just so much easier. So, but I think maybe we're going to have some questions about the Java front and why or why not, how it compares. But I think Ivan's going to probably fill us in on much of that. So why don't we let him do the talking since he's the expert on this?
All right, absolutely. We'll be quiet now, unless you guys have questions.
No, we won't. We're going to ask questions all along the way, Ivan. So don't think we're quiet.
Okay, no problem.
All right.
All right. So let's see here. First time I'm using this live stream, so bear with me just a little bit here. Let me go ahead and share my screen. All right. Okay. Just a second here. All right. You still hear me okay?
Yep, we can hear you.
Okay.
If you're sharing your screen, we can't see it.
No, not yet. Let me get
Oh,
that
okay,
here.
good. On any given day, I'm in Teams, Zoom, Google Meet, and I can't tell you how many times I have to change the settings, in whatever thing we're doing.
Yeah, I gotcha. All right. So you should be able to see my share there. Are you seeing the slide title there?
I don't see it yet. Jeremy, can you see it?
Yeah, let me.
Now I can see it.
Okay,
Cool.
that took a little bit. All right. Do we have any? Let's see. Will folks be? I see there's a chat here on the right. All right, so I'll just go ahead and get started, and you guys can stop me if there's like a question or anything like that. Does that sound good?
Sounds great. Yep.
Okay, Great. All right. So thanks everyone for joining. So I wanted to take you on a journey on how I started to learn more about WebAssembly and the things I learned along the way. I do want to mention that this technology is still a bit nascent and it's evolving rapidly. But this will give you some idea of how this technology can be used. And I'll be doing a demo showcasing some experimental ways in which you could begin playing around with it. All right, so have you seen these types of headlines? Is WebAssembly the new Docker? How about this one? When WebAssembly replaces Docker.
Oh, I love that one. That has come up so many times in the last 6 months in meetings.
Yeah.
Yeah.
Yeah, so it's quite insinuating, right? It's making you start questioning. This logically kind of leads to the question that I had: is WebAssembly the next big thing in cloud computing? It sure seems like those titles are insinuating that, right? So, but before we jump into WebAssembly, let's kind of quickly review, what is the current big thing in cloud computing? So, containers are the big thing right now. And containers radically transformed how applications were designed and deployed. So we had trends and technologies that first gained popularity with Docker. Docker introduced containers. They packaged it up nicely, gave you a nice developer experience, and then containers started to become popular, and it grew into Kubernetes and OpenShift, and now whole multi-cloud ecosystems are based around container runtimes. And you could argue probably an entire decade of cloud software innovations. So it introduced things like scalability, fault tolerance, operability, composability, DevOps, automations, all of these properties which are cloud business infrastructure that it's built around. And it's fundamental thanks to really one operating system level abstraction, the container. So from what I knew about WebAssembly, which wasn't a whole lot at the time, I thought, isn't WebAssembly a browser technology? So I couldn't, scratching my head, couldn't really think about how it would be considered a replacement for something as foundational as containers. But, I had to dig in some more. And once I dug into it, it actually seemed like the idea had some traction. So you may be familiar with this famous tweet by Solomon Hykes. And he basically was suggesting, that if WASM and WASI existed in 2008, we wouldn't have needed to create Docker. And that's how important, he views it. And so this is a reply to the announcement of WASI by Lynn Clark down there. And he, the important comment, the important part of this tweet is that, a standardized system interface is the missing link to WebAssembly. And we hope that WASI is up to the task, right? So what actually is WebAssembly? So maybe by a show of, I don't think you can do gestures here, but maybe in the chat room, who here has heard of WebAssembly?
I think a couple people have, but let's assume that if they're on here, they're trying to learn about it, but a couple of us have used it, but not in anger. How's that?
Yeah. So my goal here today isn't to convince anyone that containers is like this old technology that's on its way out, or even that WebAssembly is going to be this new miracle solution. In fact, we don't subscribe to the theory that WebAssembly is going to replace containers, just like containers didn't replace VMs. We see it as really just another tool in the developer's toolbox to build their applications. But WASM does have the potential to have quite a large impact on how cloud software could be designed and deployed. So let's start with some background on what is WebAssembly, where is it being used, and where could it be used instead of containers. So WebAssembly, abbreviated WASM, is a standard. That standard defines a binary instruction format called bytecode, and that bytecode represents low-level hardware operations. It's essentially a made-up instruction set architecture. It is supported by many compiler toolchains such as Rust, C, C++, Go, and many others to compile the native language to WebAssembly. Rust, as was mentioned earlier, is also one of the uh, more aligned languages to support WebAssembly. Originally, it was C, C++, and then Rust has gained a lot of traction in being kind of the language of choice for using WebAssembly. And so WebAssembly is an OS and architecture agnostic solution to provide kind of that build once and deploy anywhere experience. So what you can do is pick your choice of language. You can write code and compile it to WebAssembly once, and it will run the same way on any platform that has a WebAssembly runtime available.
Can I ask one thing? So we're talking about, is it going to replace Docker? So why are we talking about it in that sort of terms? WebAssembly this is a small executable that we can pass around. It's going to across environments, but we can run lots of them on top of one VM or a physical host.
Yeah, essentially, it allows you another layer of being able to utilize your hardware, right, in even a more optimized way, because you can start and stop these things quickly. They're usually lightweight, and we'll go over some of those things as well.
So I have a question, Ivan. This was asked the last time I was pontificating about WebAssembly to someone, which was, I mean, containers images are typically, in a registry. Is there some place that we can keep this in a registry? If we're going to talk about it in context with containers.
Yeah, so a lot of the WebAssembly ecosystem is starting to standardize on the OCI image or a container standard for example, for packaging an image and creating an image and storing it on an OCI registry. So a lot of the existing infrastructure and tooling can continue to be used, and I'll demonstrate some of that. Great questions. So WebAssembly is, it has a lightweight execution model. The standard enables the creation of a single-threaded. It's a simple single-threaded stack-based virtual machine. And so, what does that really mean? It basically means that um, it it it's how the virtual machine processes instructions, meaning that like the primary interaction is moving values to and from a stack with push and pop operations. So this, for example, significantly reduces the number of CPU registers required, and it's one of the reasons it makes the VM more portable across different architectures, because you're less reliant on the CPU architecture's register file. So these VMs run standalone in user space, and they also support being embedded into existing software using a sort of like a plugin architecture. And in the web, traditionally, in the web, the browser, in the web browser, which is where you might be more familiar with WebAssembly, the runtime there is actually some kind of like JavaScript engine like V8. And then the VMs support just-in-time or ahead-of-time compilation, and they also can be interpreted as well. And ahead of time will give you that near native speed that you can get with WebAssembly. So WebAssembly is also an isolated sandbox. So by definition, the WebAssembly.
Sorry, yeah. I had a question, which reminded me of a question that I had. So Dreaming HK asked, how is this different from Java bytecode and the JVM? And I noticed a couple of things on that slide. Just-in-time compilation, AOT, right? This reminds me a lot of Java, right? And the way Java works. So how is this different? And like, why would I choose this instead of, say, choosing a JDK?
Yeah, so that's a great question. That question does come up. It's quite a large and loaded question to answer just here, but I can give you some and there's great articles that have kind of tried to capture some of this stuff, and I'll give you some of the bits of what I've learned along the way. So Java is, so you can see a lot of similarities with the bytecode and the JVM. But one of the things that's kind of fundamental is that Java wasn't originally designed to support kind of multiple languages like this, right? Like the interoperability with different languages is not something that it was designed for. It was something that people ended up doing anyway. And so an opcode was added eventually to kind of support that use case. The other thing is that Java kind of has lost out in the web browser. Whereas WebAssembly, we originally had Java applets, if you're familiar with that back in the day, and there were a lot of security issues with that, performance issues, maintainability issues, and as JavaScript got faster, more JavaScript code was written, and then eventually WebAssembly was a more optimized solution to get a lot of performance to the point where eventually WebAssembly was adopted into the web platform. So along with HTML, CSS, JavaScript, WebAssembly is now kind of part of the web platform. So Java is already kind of lost out there, and that's a big edge for WebAssembly. Then there's other more like nuanced things that are different around like the structure of the bytecode. For like a JVM, for example, is more unstructured versus with WebAssembly, it's more structured. And what I mean there is that like the operations that will execute in WebAssembly are like if equals, and you'll have common loops and things like that. Whereas with the JVM, you'll have like go-tos and you can jump around in the code quite a bit, and it's not quite as structured as WebAssembly is. So there's various things like that. There's also the memory management piece, which comes with its pros and cons. With JVM, you don't really have to think about it as a Java developer. Like it's all handled underneath. There's a garbage collector. You can do certain library calls to do some things, but like in general, you don't have to worry about allocating any memory. It's all handled kind of for you. Whereas with WebAssembly, you have to do it manually. So like it doesn't come with a garbage collector. You can do pretty much anything you want with the memory, which has that power and flexibility like some of those compile-based languages like C and C++ and Rust. And so this is kind of why those languages tended to be, at least for right now, the more popular languages, because they don't come with memory management by default. You have to do your own memory management, and then it gets compiled into WebAssembly. So there's a lot of differences along the way there that are different from what Java and the bytecode and the JVM have done. So I kind of touch base on a few of those things, but we can go in. I mean, you could have presentations on each of those topics in more detail. Does that help answer the question there?
Yeah, I think that's a good answer.
Yeah, I think that's a good segue though into you mentioned ahead of time compile, interpreted compile, and JIT compile. Maybe if you could maybe spend 30 seconds elaborating on the differences there, because they each imply something.
Yeah. So so these are really the virtual machine. The WebAssembly virtual machine has different ways to parse the bytecode and compile it to the native instruction set architecture where that WebAssembly virtual machine is running. And so with interpreted, you're really just interpreting kind of like a scripting language would interpret a script, right? So you have Python would interpret your Python's script. It would essentially be similar, and you'd have an interpreted level, which is the slowest but more portable approach. And there's certain benefits to that on why you might want to use that. With just in time, you get your bytecode, and as you're executing it, the virtual machine will kind of optimize things and recognize patterns and try to do some compilation. Um, when some piece of code is being reused, it will try to optimize it and try to compile it so that you can then execute it a lot faster when you come around. And then there's certain like heuristics that are used around, is this constantly hitting, if there's a comparison, for example, is it the comparison typically true? versus false, it can try to optimize things along the way. So that's why they call it kind of just in time. And it's still a very portable approach, where the WebAssembly VM is executing that code on the native architecture, where it's getting a WebAssembly module that's in the bytecode format. With ahead of time compilation, you have the ability to run near native, because what it does is it's kind of a deployment style technique where you're essentially doing a compilation of that bytecode into the native instruction format, kind of at deployment time. So before you're executing. The problem with that is you do lose some portability, right? Because now you kind of have to move your bytecode isn't JITted, so it's not quite as portable because it's already compiled to the native instruction format. So you kind of have to, if you want that near native speed, you kind of have to have a trade-off between portability and speed a little bit. But JIT is still very fast, right? So it's not like it's not usable. In fact, that is the more common approach to using WebAssembly. Does that touch base on it a little bit there? Help answer any of those questions? It's a little bit more than 30 seconds.
Yeah, that's okay. No, I think that's great. Some people, they're coming from maybe the Java background. They're used to JIT. Ahead of time compile has that implication that I'm going to have to target a platform in order to do it. So it's not going to be portable like WebAssembly should be, right? So that removes one of the key features, which is the portability. And then the interpreted bit is like, well, what does that mean? Can I just throw Python in there and start running Python or something like that? Right? So I'm glad you answered that. Thank you.
Yeah, no problem.
We get a couple of questions too. So around multi-threading. So somebody asked, who is it? Robert asked if there are any plans to make WASM multi-threaded, and Demir asked thread cooperative multi-threading, and Rob had already talked about this a bit. So not to hijack you again, but we got some interest in multi-threading. You guys want to take that? Rob, tell us if you have some background here too.
I don't know, Ivan. The way I answered it was, basically today multi-threading is not really there. You're kind of tricking it out using web worker-based threads, and JavaScript. But multi-threading is on the agenda, kind of roadmap to be added. I don't know what else you want to add there. Personally, I kind of would get a little scared of multi-threading in that environment because I don't know why I'd need it. But if we're talking about server-side WebAssembly versus WASM in the browser, then it might be more pertinent because we can do that today in containers, even if we shouldn't be. Kind of thing. Yeah.
Yeah, so that's exactly right. They're working on a WebAssembly. They're working on adding threading to the WebAssembly standard. However, there are other pieces of like work that are happening in the WASI subgroup where they're trying to add threading there before it maybe becomes available in WebAssembly. I think ideally WebAssembly would be the end goal, but you can do some things with WASI by allowing you to add kind of a common API where you could call into kind of like a threading library where like pthreads, for example, and it could be implemented by the VM, the WebAssembly VM underneath, where it honors that API and provides some facilities to execute with threading. So it would be, it is another approach to how they're trying to get WebAssembly. And there's differences between the two that are a bit nuanced and things like that. But there are multiple streams of work happening to try and enable threading.
Cool. Why don't we let you get going farther? We'll waylay you when it's probably least appropriate with the next question.
Sure. Yeah. Thanks. Appreciate it. So let's see. So I was mentioning that it's WebAssembly's virtual machine is a sandbox, and it provides a sandbox execution environment with memory isolation, and it operates in a deny by default mode unless you explicitly grant it capabilities. And that's the goal of WASI, to enable a lot of that. So where is WebAssembly used? Is anyone using WebAssembly in a product or as part of their cloud strategy or anything like that? It would be cool to hear about it, your use case in the Q&A or in the chat. And maybe we could link up, afterwards, or you can send me any messages along, outside of any of the communication channels where you can find me in social media. And it'd be great to have conversations about that stuff. So for this part, let's quickly do a kind of a quick history lesson on WebAssembly history anyway. So there's kind of three main periods or evolutions of this technology that has taken place over the last few years. Excuse me 1 second. All right, need to get some water there. So where is WebAssembly being used? Well, since about 2015 to right now, obviously, it's mostly in the web browser, right? That's where it's mostly been. So it was announced by Mozilla to have WebAssembly be a safe and efficient kind of client-side compute solution that was needed. And by 2017, WASM was supported in all the major browsers. And so it continued to evolve from there. In 2019, the World Wide Web Consortium named WebAssembly that fourth language of the web, kind of joining the web platform with HTML, CSS, and JavaScript. And today, WASM drives computationally heavy backends for web applications. So there's different applications of this with 3D modeling, scientific applications, gaming, AI, ML, and some examples of that are like Adobe Photoshop moved, their desktop application to the web and be able to support that on the web. Things like AutoCAD. Then there's WebGL. Google SketchUp is another example of kind of that 3D modeling that moved from the desktop to the web, and all that was enabled by WebAssembly. All right. From there, we went to cloud middleware. So this is kind of that plugin architecture. So from about 2019 to right now, there's been a lot of use of WebAssembly as this plugin model because it's great at extending existing software with kind of customized like policies or functionality that you may want, if you want to enable your users to be able to use your software or have some sort of custom tweaks to your software through that plugin architecture. WebAssembly is a great solution for that. And there's uses of it in production out there. You may be familiar with certain control planes or service meshes and databases. So OPA, for example, the policy engine uses WebAssembly, Istio as well, and then Kuborden, and there may be some projects in Ceph that look to use that as well. And so it provides kind of the ability to run untrusted code safely in a sandbox. It's similar to like, you could think of it as like user level eBPF, for example. All right. And so from there, about 2021 to right now, you have server-side WebAssembly. So for me, this is the exciting part, right? It's what the rest of this talk will be focused on. In the previous two evolutions, WebAssembly, the WebAssembly VM was run embedded completely within another application. So the browser or existing software. But the latest trend and what the comparison of containers is kind of focused on is the ability to run WebAssembly on the server side, so standalone. And in this model, the WebAssembly VM is run directly on the host and executes the WebAssembly code that's deployed. So in 2018, the Bytecode Alliance was formed and began working on the WebAssembly System Interface, or WASI. And WASI is a POSIX-like system call layer for WebAssembly programs to be able to do certain operations that like standalone programs need to do. So these are things like reading from the file system, writing to sockets, dealing with locks, having access to a clock and random numbers and those types of things. So this is still in conjunction with the capability-based security model that WASI is intending to work with. So what that means is any resource that the WASM code can access has to be granted explicitly by the host environment. So just because WebAssembly has a way to access a file system doesn't mean that it has permissions to, and you have to explicitly tell it that it can access the file system. And so in recent years, the technology has been used drastically to speed up cloud native execution. So there's like serverless solutions. Fastly and Cloudware are two um, companies that are using it in that way, as well as like microservices approach. And you have companies like Fermion and Cosmonic that are have solutions for kind of event-driven microservices to use WebAssembly sort of as like almost like a serverless event-driven microservice. And so at this point, the original question is, well, is WASM and WASI a viable replacement for containers, just like those articles were suggesting? Well, in order to do that, let's break it down. So I've selected 5 categories here of importance for a cloud software abstraction. You have generalizability, security, efficiency, performance, and portability. And we'll go down each one and then do a comparison, and we'll take a look here. So the generalizability of WebAssembly, you have a lot of languages that can be compiled to it. You can have custom built. It's a single process runtime. Whereas with containers, you have every language, right? Every application. It's a multi-process environment. You essentially have like the entire operating system at your disposal. So generalizability, we're going to give that one to containers. We think containers have the edge there. The next one is security. With WebAssembly, you have kind of that built-in, the VM security, along with that deny by default security sandbox, kind of gives you that implicit level of security already built in, but you can explicitly provide permissions for necessary things in your application. Whereas with containers, containers have been around longer, they've been battle tested. You have namespaces and C groups that kind of provide a great level of security and isolation for implicit protection, kind of built in. But you can continue to build up that configuration and add more security explicitly through things like SE-Linux. You have seccomp. You can use rootless containers and trusted base images. So there's quite a bit of ability to add security there. So I'm going to give that one a tiebreaker. That's a tiebreaker for me. I think they both have security benefits. The next one is efficiency. So WebAssembly, you can think of like being deployed in microseconds, right? The memory footprint is really light. You can start and stop it quickly. So you kind of have a lot of those serverless features that you would want, where you don't have to deal with cold start times, and it can start instantly, and you can shut it down right away and not use the hardware or utilize the CPU and utilize the resources unless you're actually executing some code. Whereas with containers, you can think about that as being deployed in sort of milliseconds to seconds, especially if it's like the first time you're pulling an image, right? Those images can be several hundred megabytes, right? And you're pulling that down, and it takes time to pull that down. And the memory footprint, you can think of that as being like in megabytes, for example. Containers can start fast, but you think about it more in like the order of milliseconds to seconds. So for efficiency, we'll give that one to WebAssembly. For performance, for WebAssembly, it kind of varies by compilation mode. I quickly touched on, you have interpreted, you have JIT or ahead of time, and essentially the performance there, there's a kind of a spectrum of trade-off between portability and performance. With containers, you get native performance. So you get the most optimal speed there. And so we're going to give that one to containers. Portability. Well, WebAssembly is trying to target that build once, deploy anywhere solution, right? And you can't really say that with containers, because while it is more portable than like a VM, let's say, it is architecture specific. So you have to have container images that are specific to the CPU architecture that you're running on. So portability definitely goes to WebAssembly there. All right, so let's do a quick recap. So what are the key benefits of WebAssembly? Well, we talked about how it's lightweight. WASM is that binary representation of low-level hardware operations. Has that simple single-threaded stack-based virtual machine. It operates in user space, either standalone or it can be embedded in other applications. And the modules are typically very lightweight and small in size. Performance, we talked, it's interpreted, JIT, or ahead of time compilation modes to optimize for portability and speed. Near native speeds can be achieved with that ahead of time compilation mode into native machine instructions. Then you have portability. It is both CPU and OS agnostic, and various languages compiled to WebAssembly, right? We touched on that. So you can pick your choice of language and write the code there and compile it to WebAssembly once and deploy it anywhere, as it's both platform and architecture agnostic. And then it's secure, right? It runs in a virtual machine. So by definition, the WebAssembly is running in an isolated sandbox execution environment, and it has memory isolation. And it operates in a deny by default mode unless explicitly granted capabilities. So going back to our question, is WASM and WASI a viable replacement for containers? It can be sometimes. And so looking towards the future, I feel that WASM and WASI is an ideal fit for edge computing. So this is where, I think WASM has one of the greatest benefits is targeting a lot of edge computing use cases, because you have that small resource footprint that's important for edge applications. It complements embedded devices because CPU and RAM is limited. That universal binary enables seamless relocation from cloud to cloud edge and edge devices. So it's really good for moving, across the spectrum of how far, whether it's the data center or all the way out to the edge, you can relocate pretty easily. And then that security model gives the device owner kind of control with that deny by default mode. So you can have that security in that far edge device that you would need. And then lastly, the interpreted JIT or ahead of time compilation modes allow you to optimize for that portability or speed that you would need on an edge device.
Is there any plans, Ivan, do you know, is there any plans, or does it already work like on iOS and Android? When you mentioned that, Adobe's put all their apps, in the browser, it seems to me it would be really nice to be able to share, your logic from, push the same executable logic to a browser as you would to a mobile device for a lot of apps.
Yeah, actually, it's a great question. I haven't actually researched its usage on smartphones per se, so I actually couldn't answer that. But that's actually a great question. I'm probably going to go do some digging around on that.
All right. Yeah, no worries.
All right.
I'm sorry I couldn't get my mic on quick enough.
No, you're good.
I kind of had a guess on that, Jeremy, which was that it could be embedded within a PWA. And a PWA can be put into both the iOS, the Apple and the Google store. And, this is WebAssembly that's normally used in the browser. So I'm not talking about WASI, which is the server side stuff. So the PWA can run native, kind of give you the impression of a native application on, a mobile platform. But an example of somebody who's doing that is also Blazor applications, which are WebAssembly applications. They embed it into a Blazor PWA so that you can put it in a store, basically. But that's an example of a single page web application, right? And that's embedded within the PWA. So it's kind of like in the old days when we would embed something in kind of a web control or something on the app. So you could have a native app running, but you're actually looking at some kind of web, HTML kind of thing. I don't know if that's a full answer, but it's just my limited guessing on that. I haven't done it myself.
Sorry, I don't mean to derail us.
No, we're good at derailing everything, Ivan. So you probably guessed that by now. So you should see when we have like 5 people on here.
No, you're good. It's good to have dialogue like this. Well, unless there's any more questions, I'm going to jump into the demo. for server side, show you some capabilities, of server side WebAssembly and WASI using Podman and Microshift. So if not everybody's familiar with Microshift, it's a edge optimized version of OpenShift. It's like an all-in-one container that runs a lot of. It's a reduced amount of things that are running in OpenShift, but it gives you all of the core components and tenants that make up OpenShift into a single, like, all-in-one container um, that is started and stopped with systemd, and makes using OpenShift on the edge really nice. So I'm going to go ahead and demo some of those things. So let me stop sharing here. And
We should also probably mention Podman in case you haven't heard of Podman.
okay, yeah.
Podman is very much like Docker, right? So think about it. In fact, I'm glad you kind of mentioned that earlier, because earlier you were talking about would WebAssembly replace containers, and Docker has talked about this. So Docker can use WebAssembly, right? And Podman can certainly use WebAssembly. We're about to see a demo of that. So
Yeah. All right. Can you see my terminal here?
not yet. Hang on.
All right. Should be coming up.
Yeah.
Is it up? I think I see it in the live stream showing up.
Yeah, we're good.
All right. So let's quickly kind of go through. I have a demo application here written in Rust. It's simple, right? We're just gonna, just like a hello world type thing. And go ahead, make a change here. So let's save that. And let's go ahead and build it. Using Cargo, we'll build the application, and you'll want to target WASM 32 WASI. This allows you to build for WebAssembly and WASI. We'll build that. Let's quickly take a look.
What's Cargo?
Yeah, Cargo is the utility for Rust that allows you to work with your application, so you can set up a lot of scaffolding for new projects, gives you build commands, gives you basically like the ability to manage and handle the Rust toolchain using an abstraction that helps you manage your application, build it, package it, those types of things.
Okay.
All right, so let's take a look at the built WebAssembly module here, and a quick hello world. You can see here that it's 2 megs. Pretty small application here. And the reason I'm showing that is we'll look at the container image size. So let's quickly run that with WASM Edge. WASM Edge is a WebAssembly runtime. It's written in C++. It's one of the WebAssembly runtimes. There's like an RPM package in Fedora that you can install and start using, and crun, which is our container runtime, has integrations to work on executing your container, your WebAssembly container, using WASM Edge. So executing that, we can see the change that we made. So now that we have this WebAssembly module that runs right here with a vanilla WebAssembly runtime, let's go ahead and package it up into a container. And for that, we have a container file. You can see that the container file is very simple here, and it's from scratch. So this is kind of an important point here, because there's no operating system dependencies, right? We're not starting with a huge base image. We're starting with an empty layer. Like, this is just a single layer image, essentially, that's just copying the binary, the bytecode, the WebAssembly bytecode binary here into the container image. So let's go ahead and build that. We have buildup, which is Red Hat's. Red Hat originally created this builder tool to build and work with OCI container images. So we're going to provide this annotation here. This is the key annotation that tells us we're working with the WebAssembly image. And then the platform is WASM. And you can see here, this is a portable platform that can run on any architecture. And then we'll go ahead and name the image right here using the container file in our local directory. So once that's built, let's go take a look at the image. You can see the image size here, right? We had that 2.1 megs up here, and now we built the container image, add some metadata, right? And you got this like 2.2 meg container image, super small, right? Super lightweight, because all it contains is the WebAssembly module that was packaged there into the image. Let's go ahead and push that to I got an account here on Quay's, on the Quay registry. So let's go ahead and push that there. And then, so these commands were executing on my development box here. So now I'm going to switch over, and you can see I named it dev. I'm going to switch over to another window here. And this window has a split screen. So the top is it's a rel VM that's running on my development box, which is an x86, 64-bit development box. And so let's go ahead and I'll show you that. So you can see here x86, 64, and then I have a VM in AWS, and it's an ARM-based VM. So you can see that there. And let's go ahead and execute that built WebAssembly module using Podman. So here we're going to just run a container, a WebAssembly container with Podman. Here's the platform that we built for this image, the platform we targeted, and that's the image that we just built. So let's go ahead and pull that down on each of these systems. And we can see that the change that we made here for Red Hat DevNation, we went ahead and built once and deployed it on x86 and ARM. So that's pretty cool. We can have that the build once, deploy anywhere experience. But this is a pretty simple application. So let's see if we can go a little bit further and deploy this application to Microshift. So if maybe Podman running a containerized WebAssembly with Podman by itself, if that's an area of interest, you can do that, or you can run it on Microshift. So here, I'm going to go ahead and let's clear that. And here I have two contexts, right? There's a Microshift cluster running on each of those nodes. So I've got a Microshift context for the x86 system and then the ARM system here. So we're going to be switching back and forth between them. So let's deploy on this x86 here first. Show you the cluster info. You can see it's just running locally, private IP address there. And we can do a get all. No resources found. We're working in the WebAssembly namespace. So here, I'll show you a quick Kubernetes manifest. We're just going to run a pod, with a WASM workload. Here's that annotation. That's important here for indicating that we have a WebAssembly image that we want to execute. And go ahead and here's the image that we want. We can name it that, and then some other basic security specifications in this manifest that are pretty standard. So let's go ahead and apply that. And once we have that applied, let's go ahead and you can see that it's already completed. And let's take a look at the log, and we have that change that we made there. So cool. We were able to execute that WebAssembly module, right, as a container and deploy that to Microshift on our x86 system. Let's repeat that. And let's repeat that on the ARM-based system. And I'll switch to that context and show you the cluster info for this. You can see that it's running on AWS here. And let's go ahead and see that there's no resources found. So let's go ahead and apply that same manifest and get the pods, see that it's completed. Let's show the log, and we get the same information here. So this is from a main function from a WASM module for Red Hat DevNation. So we have that same change. Cool. So we built once an application, right? And we deployed it anywhere with Podman or on Microshift across two different architectures that are commonly used in cloud infrastructure today.
So we have a kind of a couple of questions. One was, what IDEs do you use? I know you're doing everything at the command line right now. I'm going to take a stab at that. And personally, I don't like Visual Studio Code, but I use JetBrains for everything. So if you have IntelliJ, there's a plugin for Rust, and it comes with the WASM plugin, which works pretty nice. And if you do use Visual Studio Code, you have to install. It works, but you have to install like 5 different extensions for it, and not all of them are coming from. Some of them are coming from individual, people. So that's something. The other one, can you show us again? Just run like C-run version and grep for WASM Edge, just to show where. Yeah.
So here, C-run version, you'll know that it's built with WASM Edge support because there'll be a flag here. These are compiler flags, and you can see that it has it there, as well as the ARM-based system here.
So what I personally do now is I'm using a RHEL or Fedora VM, but I have a Mac, right? So I have that with the ARM-based Mac. But when I use Podman, I can't change the C-run underneath Podman right now on the Mac. But what I'm told is that, and there's no promises here, that the next version of Podman will support this out of the box. Again, I'm not making any promises, but I'm under the impression that that's going to happen. So then I can now run it natively on my Mac, because what I normally do on my Mac is I run Podman and I alias Docker to Podman, so that all my tools in my IDE will work with Podman instead of Docker. I don't know what are you on? Are you on a Fedora machine, or are you on a Mac?
Yeah, okay. I'm on Fedora 37.
Okay. There's a question Robert asked that said, what about if I have WASM in a container, is there integration with config maps and secrets on Kubernetes? That's a great question.
Yeah, so the downstream API, you can pass certain things as environment variables, and you can get access to environment variables. So that would be one way, for example, that you can pass things like that. For certain things like secrets and config maps, a lot of times those are mounted into the container as files. So you can get access to those things through WebAssembly just by providing access to the file that's on the host, right? So you can provide the same sort of mapping. It needs to be done a little bit differently, and there's work that still needs to be done around being able to provide a lot of the capabilities and parameters that you might need to make your application run successfully. So these are things like if you wanted to have AI, ML capabilities that are built into the WASM Edge runtime, we are working on what does that mean to the OCI standard, and the config needs to specify that, because ultimately you have a Kubernetes manifest that gets passed down and translated to an OCI config that then CRUN sees and executes and provides the right execution context for the container. So those types of parameters and options need to be kind of decided on and figured out so that we can provide a lot of those features and capabilities.
Cool.
While folks want to ask a question, go for it. I'm going to go ahead and try to zip through another example here, a little bit more interesting example for running an HTTP application. So if folks are there any other questions?
I don't see any in the chat right now.
Do this in Rust?
Say it again?
Is it easier to do this in Rust or JavaScript? Or the same?
I would say Rust is the more WebAssembly friendly language today. So I would have a probably biased opinion that it would make it, this would be easier in Rust. But I'm not a JavaScript developer, so feel free to challenge me on that.
Okay.
So this is a basic HTTP web application that just it basically just echoes your request back to you, the data that you pass in, and we're gonna just open a connection on port 1234 here. See, we have a handling the client here. We decode the information using our handler here, and then we create a response up here to handle that request. We can see that we're going to just echo this back, echo the body back to the client. So pretty simple. Go ahead and build this and target the same WASM 32 WASI. I've already built it, so it's kind of optimized there. So let's go ahead and take a look at that binary. We can see we have 6.5 megs. So again, pretty lightweight. I'm going to skip running it on WASM Edge directly because we've seen that. So let's just go straight to running it.
And that's the debug version. The release version would be much smaller, right?
Yes, that's true. So if you add a release here, which hasn't been compiled yet, let's do 2.3 megs.
Yeah.
So even much smaller. Thanks for pointing that out. So again, the container file here for building the container image, same thing, right? Just a scratch image. All we want is that HTTP server in the OCI image. So we're going to go ahead and build that. Same build command essentially, right? Just a different target registry repo. And once we build that, let's take a look at the image. Again, pretty much the same size as the binary, and this is the debug, not the release version, right? So let's go ahead and push that. All right, so going back to our two instances here, these are the x86 and the ARM-based VMs. So let's just give you some context for that again. And then let's go ahead and run it with Podman. So again, we'll run it with both capabilities, Podman and Microshift. So here we have Podman running. So let's go back to our dev box. Podman is running that WASM container. And so let's go ahead and we're going to go ahead and clear here some context. And so here I'm going to do a curl using the x86's IP address and port. And here's that HTTP server just echoing back the data here. So we can deploy that once to the x86 VM, and let's do the same thing for the AWS ARM system. So there we go. Got them both executing there. Pretty cool. Let's go ahead and kill that here. All right. So now let's go ahead and deploy to Microshift again. All right. So I'll breeze through this real quick. Got a couple minutes left, but see the Kubernetes manifest for this. You can see that it's pretty much the same thing. Here's that annotation again. Image, here's the command, some port options here, and the rest is pretty much the same. So let's go ahead and apply that. And let's go ahead and expose that as a node port service. And let's check out what node port we got. All right, so now that we know the node port, go ahead and curl with that IP address and that port. Cool. So we deployed to Microshift on the x86 VM, and we can see that we have same output. I'm going to switch to the ARM Microshift context now. And the same Kubernetes manifest, and expose that. See here. All right, it's running. I'm going to expose that and see what port we got. All right. And now let's go ahead and curl that on that port. All right, there we go. So we basically, again, built the HTTP server once and deployed it anywhere with Podman and on Microshift running on each of those systems. So looks like that build once, deploy anywhere is holding true here, and shows pretty promising technology. Any questions?
No, I think that I have had some discussions with some folks about, shipping edge devices that are like x86, and then the downstream devices aren't going to run like a K8 on them, and then they are ARM, but they want some of the same kind of feature functionality for who they're working with, and this is very pertinent, I think, for that kind of discussion from for edge customers. I don't know, from the perspective of what would you do though if you were going to target ARM? Would you do ahead of time compile, or just because running on two different targets the same application is interesting, but I guess I would be interested in what would be the size and performance difference, when I actually target the platform, either I'm going to go to ARM or I'm going to go to x86 versus maybe a JIT compile or something like that.
Yeah, so I think that's on a case by case basis, right? I think each individual application of this technology would probably have to make a decision on what trade-off they're willing to make or that they would need to make. JIT is still pretty fast, but you get more speed up, of course, with ahead of time. So if the most optimal speed is important, but you still want some of the other like polyglot capabilities of WebAssembly, where you might have multiple pieces of your application written in different languages, and you all want to target WebAssembly, but still maintain the most optimal performance, and you don't mind having a deployment strategy where you ahead of time compile like upon deployment, then I think that would be a good way to go. But if you still want to keep the most portability, or at least more portability than the ahead of time compilation, still pretty fast and capable, but kind of not want to introduce another step into your deployment pipeline, then certainly you can just deploy with a JIT based compilation. So I think it just depends. It's going to be a case by case basis on what users end up wanting to optimize for.
Now, Michael Dawson, is he doing WebAssembly too? I know he's, the Node.js, on the Node.js team, but I haven't spoken to him about, is he doing WebAssembly? Because I know a lot of the JavaScript guys have kind of shown a lot of interest in WebAssembly. Is that?
Yeah. So that is potentially another prominent WebAssembly runtime is Node.js, because it leverages V8, which has WebAssembly support in the browser, of course. So it can implement and that outside the browser with Node.js, but there is still work needed to enable the WASI APIs, and now WASI is even moving to preview 2, and there was still work that needed to be done there. So They're still working on it, but there have been some hiccups and roadblocks to doing that, as I understand it. So it's still going to take time, but that could end up being another viable runtime for sure.
Cool. Well, I'm glad you showed Podman, because we're going to have on next month several people from the Podman team, actually, and the
Oh, cool.
Podman desktop team. So they're going to be talking about all things Podman next month, and Podman desktop. So I think that was a really good segue for us. So I really appreciate that. But another question that keeps getting asked is, maybe this would be a good one to close out, because you can expand on this a little bit. Was do you see people using this more for doing the AIML now, like bringing that down into the edge or the browser? And you think it's good for that?
Yeah, so I think a lot of edge applications or WebAssembly is good to target a lot of edge based applications. And one in particular that I think is also has a lot of benefits to using WebAssembly is AI, specifically AI inference, because you're not necessarily going to be training a model on these far edge devices. You've already got a trained model to work with. And there's a WASI NN proposal stands for neural net, and that proposal allows a common API and the WebAssembly, so you can write your code to that common API, to leverage essentially any of the ML frameworks, and the WebAssembly runtime will have integration points with the different ML frameworks. So TensorFlow, PyTorch, OpenVINO, Onyx, and those ML frameworks are able to be integrated with the WebAssembly runtime, and they abstract out the common API that you would need access to be able to use any one of those. So it's a really nice feature that a lot of them are working on and have enabled capabilities of doing, and so, yeah, I think AI workloads are definitely an area of interest, and a lot of these WebAssembly runtimes have targeted them for sure.
Cool. Well, we're at our time, and I really appreciate you joining us this month, and thank you very much. We look forward to having you on again, and maybe seeing a little more, where WebAssembly's evolved in the new year, and maybe discuss a little more of the things that we have going on with it. So I don't know. Anything to add, Jeremy, Ivan, before we drop here?
Yeah, special thanks, Ivan. Getting up this early, you're on the West Coast, so this is really early your time. You guys can just watch the sunrise behind me and Rob, and it's not Ivan yet. So thank you very much for joining us this early, and thanks to everybody who joined and asked questions. Feel free to contact us anytime. You can get in touch with me at jeremy.davis@redhat.com. Rob, what are your RC?
Just rcdor@redhat.com. Yeah.
If you ever want follow-ups or anything else, feel free to reach out to us. Thank you for joining.
Thanks, Jeremy. Thanks, Rob. I really appreciate for having me.
Thank you again, Ivan.
Yeah.
Appreciate it.
You're welcome.